Welcome to the last video of this section, building a speech recognizer. In the previous video we looked at building a hidden Markov model. In this video we'll build a speech recognizer that can recognize 7 different words. We need a database of speech files to build our speech recognizer. We'll use the database available at code.google.com. This contains 7 different words where each word has 15 audio files associated with it. This is a small dataset, but this is sufficient to understand how to build a speech recognizer that can recognize 7 different words. We need to build an HMM model for each class. When we want to identify the word in a new input file, we need to run all the models on this file and pick the one with the best score. We'll use the HMM class that we built in the previous video. So now we use here the speech recognizer.py file again, and then we import these packages in the initial lines. Now we define a function to pass the input arguments in the command line. Next we define the main function and pass the input arguments. Let's initiate the variable that will hold all the HMM models. Then pass the input directory that contains all the database's audio files. And now extract the name of the subfolder. The name of the subfolder is the label of this class, so extract it using this line of code. Let's now initialize the variables for training. After this, iterate through the list of audio files in each subfolder. Read each audio file with these lines of code. Now extract the MFCC features, and then keep appending this to the X variable. Next, we append the corresponding label too. Once you have extracted features from all the files in the current class, train and save the HMM model. As HMM is a generative model for unsupervised learning, we don't need labels to build HMM models for each class. We explicitly assume that separate HMM models will be built for each class. So here we insert the code for it. Now, get a list of test files that were not used for training. Let's pass the input files as this, and now read in each audio file. Next, we extract the MFCC features. Let's define variables to store the maximum score and the output label. We again iterate through all the models and run the input file through each of them. Let's extract the score and store the maximum score. Finally, we print the true and predicted labels. And this is the line to suppress warnings that are generated, so you can add it into your file whenever you want. Let's now move on to run our code. The full code is in the speechrecognizer.py file. As you run this file, you get the output with the true and predicted output the data we provided. So, now we know how to build a speech synthesizer. In this section we began with reading and plotting audio data, and then we transformed audio signals with customer parameters. We also synthesized music, extracted frequency domain features, built hidden Markov models, and finally we built a speech recognizer. In the next section we'll be dissecting time series and sequential data.